Okay, this will be the last video in this lesson, this series. And let's go back to the main screen. And so you can, to do that, you come down here on your SolidWorks icon and hover over it. It shows you what's open. And we could probably actually close this pin dialog. We'll just click Save All. I'm going to hover over this again. We're going to and just click on it, and it will open up whatever window you click on. So we've got our main assembly, and if I go up here to Insert Components, it brings up crank sub 1 because it's still open, but we could also search for that as well. And so I can just click on this, hold it, and just drag this out, and there's my and then I can just place it here somewhere. And so again, this is my sub-assembly. It comes into my main assembly already assembled from what we did before. And like I said in the previous video, this is done all the time in industry. And maybe you've got a part, maybe you've got 10 parts in your factory that uses this same combination of parts to make this handle assembly. Well, now I can use that sub-assembly in all 10 other assemblies, and I don't have to recreate that every single time. So to do this alignment, the book says use SmartMate again. Well, we've done that. We're just going to do regular mate. And so I'm going to come up here, and if I tilt this, we're going to select that diameter inside that bore, and then I'm going to select the shaft, and we get a concentric mate. We're going to say okay. I'm going to lift this up for now, and now we're going to do a parallel mate. So I'm going to tilt this up, and there's a flat on the inside of that crankshaft, is what they're calling it, and we're going to select that. And then we're going to select the flat on this cylinder. And it gave me a coincident. I'm going to change that to parallel. And so we can see that they are parallel, but they're not lined up. And a couple videos back, we talked about alignment and anti-alignment. And so because I had selected this face from the inside, this face going, I guess, in this direction, and this surface are facing in the same direction, and that's what it thinks we want. And so this is where we want anti-alignment. Basically, we're going to flip the way that those are aligned. And so if I select anti-aligned, you can see it flip that handle around. And now this surface is lined up with this. And so we're going to say, okay, because that's what we want. Now that flat aligns with that. So now we need to bring this handle down, right? And so for this mate, we're going to use what we call a distance. Because as we bring this down, there needs to be a little bit of clearance between here and the bottom of the cylinder. Otherwise, it's going to rub or it's going to be too high. And so we're going to use what we call a distance mate. And so that is this selection here. It's got these arrows, looks like a little distance. And if I select that, it allows us to select a distance. It also allows us to, I think, change units. We'll see here. I'm going to type in 1/32, because that's what the book says. And then it gives us a chance to do units. And so we'll say inch. And we're going to select this surface. And this surface. I'm going to say okay. You can see it brought it down, and there's, if I bring this around, there's a little bit of clearance now between the bottom of that and the top of our bracket, so it can rotate freely around there. All right, let's say okay. And a couple things to notice is in my feature tree under my crank sub, if I look at that, I've got all the components in that sub assembly. So again, and then I could open each one of these and it would show all the part components for that crankshaft and how we made it. So again, very detailed amount of information, but it shows us exactly how we made the part. Under our mates, if I wanted to know, if I looked at this distance, if I click on that our distance mate, it's going to give me the distance on the screen. And if I bring this around, because my template is in metric, even though we put the distance in inch, it's showing as 0.79 millimeters. But again, it's just stuff that we've got that information at our fingertips if we need it. Okay, let's zoom out here. And now our assembly is complete. And if I go up here and give ourselves an isometric view, I can use my dynamic motion and I can crank this around using the handle, and I can see how that is going to move. Now there's one more thing with mates, and I may want to position this for like a drawing or something. And if I come into mates and I've got an option down here for positioning only, and if I click that and say that I click that surface and I click this surface, I can align this temporarily. And again, this, maybe I want to take a snapshot of this or something in a certain aligned position. I can click OK. Now I can still move that, but what it did is it just aligned it temporarily so I could, again, take a screenshot of it or something like that. So the last thing we're going to look at is how to save an assembly. And it kind of describes it on page 479, but what we're going to use is Pack and Go. And what Pack and Go does is not only does it save the assembly, but it saves every file or every part that was used to create that assembly. And this is incredibly valuable or useful, I should say. If you ever have technical support with a drawing and you need to contact SolidWorks, or this works on CAM programs as well, they want to see typically a Pack and Go file so they've got all the information. The other place that you're going to use this is collaborating with other people that you're working on the same project. And then last, you're going to use it in this class because when you submit an assignment that has an assembly, I need to see the Pack and Go. Otherwise, I'm not able to open up the assembly. The assembly opens up for a brief minute, it shows the components on screen, and then I get an error that says cannot locate the components because those aren't the ones that you sent to me. You only sent me the assembly. And so when you turn in like this file or you turn in your final, it's going to need to be in a Pack and Go. And the way that we do that, we just go up to File. We come down here to Pack and Go. Oop, I clicked on the wrong one. So this can happen for a number of reasons. You may or may not get it. And one of the ways that I know how to fix this, and I think it's the fix that I know is good for a lot of reasons. Hopefully it'll fix this one. But if we hit OK, we don't. Okay, so there's a couple different ways that you can fix that error if you get it. There's no saying that you are going to get it. And probably the easiest one is you can go in and you can repair your installation. And if you go in and you find your SolidWorks installer, You can go in there and there's, instead of reinstalling it, it will do a repair. The other way you can do it, and I'm not going to show you how to do it because I don't want to have anyone messing with their computers and then say I did it, but you can Google it on, or you can look for it on YouTube, and there is a repair for that, error. So anyway, as I was saying, we're going to go up here to File. We're going to go to Pack and Go. And this is what you're going to see. And it shows every part and assembly that is in, or subassembly that is in this file. We want to flatten to a single folder, and then I can either save this somewhere or I can save it as a zip file if I want to send it. So again, this is what you're going to do when you send stuff to me that contains an assembly in multiple files. Otherwise, I'm not able to read it and grade it. So go ahead and save this part. We're going to end this here, and then you're going to be able to hand this in.